It's Friday, September 18th. Today we're going to talk about color mixtures. And I love this lesson. I've done it for a couple of years now. When were you in the classroom, we would have cylinders and we would have water and food coloring. We'd actually mix up this water so that you could see the changes going on. But as it is now, we're just going to have to make do with drawing. Making drawings of our color mixture. So if you've got any colored pencils and you want to grab them now, that would be great. Okay. Your learning target today is kind of lengthy again. You can pause the video while you copy these down. I can explain the meaning of equivalent ratios using a color mixture as an example. I can use a diagram to represent a single batch, a double batch, and a triple batch of a color mixture. And we actually did some of that yesterday, so this is not new for you. And I know what it means to double or triple a color mixture. And doubling and tripling a color mixture is not really any different from doubling and tripling a recipe. So I want you to pause the video so you can write down your learning target. Okay, so going back to our fluency and number talks, finding the product of each value mentally, 6 times 15. I really like to decompose some numbers. I really like decomposing. So I'm going to give you about 3 minutes to see if you can come up with some mental strategies. Please don't put pencil to paper. This is about finding them mentally. Okay? So pause for about 3 minutes. Okay, so this is what I mean when I say decompose. I took the 15. I had 6 times 15. So I broke the 15 down into 10 and 5. So I multiplied 6 times 10 and 6 times 5 and got 90. Okay? So then we had 12 times 15 was the second question. 12 times 15 was the second question. Well, if I recognize that 12 is 6 times 2, isn't my answer going to be times 2? Since the 6 from the first question doubled to 12, the 15 stayed the same, the product doubles. This is because there are twice as many groups of 15 than in the first question. Okay? So then the next question is 6 times 45. Well, I go back to my original 6, but what's the relationship between 15 and 45? It's triple, isn't it? Or times 3. So 270. 9 times 3 is 27. 90 times 3 is 270. Okay? And then the last one, 13 times 45. I could double this 6 to make it 12 and then add one more group of 45. Okay? The 45 is the same as the previous question. We can double the 6 and the product goes to 540. And then add one more group of 45. So 540 plus 45 would be 585. All right, any questions? All right, so today we're going to talk about color mixtures. And so it says your teacher has mixed milliliters of blue water and milliliters of yellow water in the ratio 5 to 15. So how many blue squares will I have? How many blue squares will I have? Well, of course, I'll have 5. And 15 yellows. 15 yellows. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's a lot of drawing. Now, The first question says, draw a diagram to represent the amount of each color that you will combine to double. I had 5 blues originally. What's 5 doubled? Well, of course it's 10. And then I had 15 yellows. What's 15 yellows? That's going to be 30. So this is what my diagram should look like. I got one batch, and then I just duplicated it. Okay? We're going to skip B. If we were in the classroom, we'd be doing this. But, all right. So, the double batch. What's the ratio in the double batch? Well, the ratio in the double batch is 10 to 30. 10 to 30. Right? 10 to 30. Is that what was in the original? Well, what was in the original? 5 to 15. How do I go from 5 to 10? Well, I multiply by 2. How do I go from 15 to 30? Again, I multiply by 2. Okay? So there's your explanation. 10 to 30 is equivalent to 5 to 15 because it's 2 batches of the same recipe. And it will create an identical shade of green. So then we talk about tripling the original recipe. Well, tripling the original recipe, you would just add one more set. Again, we're going to skip over B. Okay. Triple the recipe. Let's write that down. 5, 10, 15, right? 15 blue. Blue to yellow. 15. Yellow, I had 15, 15, 30, 45, right? Is my ratio equivalent to, is this ratio equivalent to what I did initially? This right here. In other words, is 15 to 45 the same as 5 to 15? Absolutely, it certainly is, because right here, okay, 15 to 45 is equivalent to 5 to 15 because it is 3 batches of the same recipe. You know, if you'll draw these things out, it will be very easy to see. Very easy to see. All right. So next, and we're not going to do all of these either. Next, invent your own recipe for a bluer shade of green. A bluer shade of green. Well, initially we had blue to yellow as 5 to 15. If I want it bluer, am I going to have to add more blue or more yellow? Well, of course, I'm going to have to add more blue. But if I double the blue and double the yellow, is my ratio going to stay the same? And the answer is no, of course not. Okay? No, it was not the same shade of green. The first and second parts were not respectively obtained by multiplying 5 and 15 by the same number. Okay? For ratios to continue to be equivalent, we've got to multiply by the same number. Okay? Are there any questions? Okay, what I want you to do now is go back to your Canvas page. There is a link there on Friday that says a recipe for orange water says mix 3 teaspoons of yellow with 1 teaspoon of red. For this recipe, we might say the ratio of teaspoons of yellow water to teaspoons of red water is 3 to 1. Write a ratio for 2 batches of this recipe. You may want to draw a picture before you write that ratio. Then you're going to write a ratio for 4 batches and explain why we can say that any 2 of these ratios are equivalent. Again, please go to Canvas and do that on the link that is there and submit. Okay? And then lastly, on Thursday, I ask you to start working on R1 and R5 in IXL. Please continue to work on those. Please continue to work on those. I will be updating grades periodically, and progress reports go out on the 28th. All right. Happy Friday. Y'all have a good weekend.